shows up every day, from the dawn to the dusk. Our lives are what defined on the basis of its presence. It's there always, but we can't directly see it. We love to be in its presence, when it's just yet to arrive as well as when it's yet to go. Yes, it's our star, the sun. The closest star to us. The sun is the star at the center of the solar system in which we coexist. We quarrel, we play nuclear wars, just like that, yet aspire to live in peace. Cultural and historical perspective. Sun, preserving life since its origin, got a special hierarchical position in human minds. And, chariot being one of the early royal vehicles, was owed to this critically required entity. Sun. During the 3rd century BC, Aristarchus of Samos, ancient Greece, first proposed the theory that the sun is the center around which the planets move. Worshipping sun was central to civilizations such as the ancient Egyptians, Incas of South America and Aztecs of Mexico. In religions such as Hinduism, the sun is still considered as a deity. The Egyptians portrayed Ra, the sun, as being carried across the sky in a solar barks, accompanied by lesser gods. To the Greeks, he was Helios, carried by a chariot drawn by fiery horses. From the reign of Elagabalus in the late Roman Empire, Sun's birthday was a holiday celebrated as Sol Invictus, meaning unconquered sun. One of the first people to offer a scientific or philosophical explanation for the sun was Greek philosopher Anaxagoras, who reasoned that it was a giant flaming ball of metal, and that the moon reflected the light of the sun. During the early years of the sun's energy was a significant era. The source of the sun's energy was a significant puzzle. Lord Kelvin suggested that the sun was a gradually cooling liquid body that was radiating an internal store of heat. Formation. Sun was formed approximately 4.6 billion years ago. Most researchers believe that our sun and the rest of the solar system formed from a giant rotating molecular cloud of gas and dust known as the solar nebula that consisted mostly hydrogen and helium. As an effect of its partial collapse, because of its own gravity, it spun faster and flattened into a disk. Most of the material was condensed to form a burning ball of gas that we now know as our sun. And this is the nebular hypothesis, which is most widely accepted. It's also believed that one or more supernovae must have occurred in the vicinity of where the sun was formed. A shock wave from nearby supernova could have triggered the formation of the sun by compressing the matter within the molecular cloud and causing certain areas to collapse under their own gravity. Most of the matter gathered at the center, whereas the rest flattened into an orbiting disk, later forming the solar system. Gravity and pressure within the core generated a lot of heat as it accumulated more matter from the surrounding disk, eventually triggering nuclear fusion. The sun is one of more than 100 billion stars in the Milky Way galaxy. For a star, it is relatively young, part of a generation of stars known as population I, which are relatively rich in elements heavier than helium. It is often said that the sun is an ordinary star, as there are many others similar to it. But there are many smaller stars than larger ones. The median size of stars in our galaxy is probably less than half the mass of the sun. Our sun, the solar system and us with it, are located in the Orion Cygnus Arm-Orion spur of the Milky Way galaxy. The numbers. The distance between Earth and the Sun is called 1 astronomical unit, AU, which is approximately 149,597,871 kilometers. The distance between Earth and the Sun varies from 147 to 152 million kilometers. Light from the Sun takes 8 minutes 19 seconds to reach us. Its visual brightness, B, is 26.74 brighter. It appears about 400,000 times brighter than the full moon. The Sun is a G-type main sequence star, G2V, based on its spectral classification. In spectral class label of G2V, G2 indicates its surface temperature, 5,505 degrees Celsius or 5,778.15 Kelvin, and V denotes that the Sun is a main sequence star, and generates its energy by the nuclear fusion of hydrogen nuclei into helium. In its core, the Sun fuses about 620 million metric tons of hydrogen each second. Fun fact, interestingly, the Sun loses 5 million tons of material every second. This is because there are many nuclear fusions that take place on the surface of the Sun. This is when two atoms fuse together to form one atom and release immense heat. It's metallicity. It's the abundance of elements present in an object that are heavier than hydrogen or helium. Z equals 0.0122. Stars with a higher metallicity than the Sun have a positive logarithmic value, whereas those with a lower metallicity than the Sun have a negative value. Angular size of the Sun is 31.6 to 32.7 minutes of arc. The angular size, angular diameter, apparent size, or apparent diameter is an angular measurement describing how large a sphere or circle appears from a given point of view. Our Sun's mean distance from Milky Way's core is 27,200 light-years. Its galactic period ranges from 225 to 250 million terrestrial years. Galactic period, also known as cosmic year, is the duration of time required for the Sun to orbit once around the center of the Milky Way galaxy. Our Sun's velocity is approximately 220 kilometers per second, orbit around the center of the Milky Way. Approximately 20 kilometers per second, relative to average velocity of other stars in the stellar neighborhood. Approximately 370 kilometers per second, relative to the cosmic microwave background. Its equatorial radius is about 696,340 kilometers and equatorial circumference is 4.379 million kilometers. Its flattening is 0.9 times 10 raised to 5. Flattening is a measure of the compression of a circular sphere along a diameter to form an ellipse or an ellipsoid of revolution, spheroid, respectively. Other terms used are ellipticity, or oblateness. Its surface area is 6.09 times 10 raised to 12 square kilometers, that is, 12,000 times Earth's surface area. And its volume is 1.41 times 10 raised to 18 billion cubic kilometers, that is about 1,300,000 times Earth's volume. Its mass is 1.9884 times 10 raised to 30 kilograms, that is about 333,000 times Earth's mass. Sun's average density is 1.408 grams cubic centimeter, that is about 0.255 times Earth's average density. Its center density, modeled, is 162.2 grams cubic centimeter, that is about 12.4 times Earth's center density. Its equatorial surface gravity is 274 meters s superscript 2, which is 28 times Earth's equatorial surface gravity. The escape velocity from the surface of Sun is 617.7 kilometers per second, that's 55 times Earth's escape velocity. Luminosity of the Sun is 3.828 times 10 raised to 26 watt. It has a rotation velocity, at equator, of 7.189 times 10 superscript 3 kilometers. Our Sun is composed primarily of the chemical elements hydrogen and helium. They account for 74.9% and 23.8% of its mass in the photosphere, respectively. And the other heavier elements like oxygen, carbon, iron and so on account for the remaining less than 2%. It is informally and not completely accurately referred to as yellow dwarf. Its light is closer to white than yellow. The Sun is made up of layers of materials, like an onion. Photosphere. Photosphere is the lowest layer of the solar atmosphere. It's simply the solar surface that we see when we look at the Sun in visible light. It heats up to a temperature of about 6,000 K. Solar granulation refers to the cell structure, or bubbly appearance, of the photosphere. Photosphere is preceded by convective zone, radiative zone and the core. And beyond the photosphere, solar atmosphere consists of chromosphere, corona and solar winds, an outflow of gas from the corona. And there are jets of dense gas ejected from the chromosphere called spicules. They extend up to 10,000 kilometers and although they fall back to the Sun, they are thought to contribute to the solar wind by feeding material into the corona. Approximately 100,000 spicules are active on the Sun's surface at a given time. They rise from the lower chromosphere at about 20 kilometers per second to a height of several thousand kilometers. Within 10 to 15 minutes they disperse or collapse. Sunspots. There exist sunspots on the Sun. These are the regions on the solar surface that seem dark as they are cooler than the surrounding photosphere, around 1500 Kelvin. They only appear dark in a relative sense. Sunspots usually appear in pairs of opposite magnetic polarity. Their number varies approximately according to the 11-year solar cycle. The largest sunspots observed had diameters of about 50,000 kilometers, which makes them so large that they can be seen with the naked eye. Span of sunspot may vary from few days to a few months, and are carried around the surface of the Sun by its rotation. They often come in groups with more than 100 in a group. Interestingly, sunspot groups with more than 10 are quite rare. Corona. Corona is the outermost region of the Sun's atmosphere. It is made up of plasma, hot ionized gas. Its temperature is approximately 2 million kelvins, and has a very low density. It continually varies in size and shape as it is affected by the Sun's magnetic field. It shines only about half as brightly as the Moon, not visible to unaided eyes due to light being overwhelmed by the luminosity of the solar surface. When light from the photosphere is blocked by the Moon, it permits one to observe the corona during a total solar eclipse. It can be studied under non-eclipse conditions using a special telescopic instrument called a coronagraph. Corona is Latin for a crown or wreath. The Sun's aurora is the shape of a crown when seen during an eclipse or through a coronagraph. Thus is why it is called a corona. Solar flares. A solar flare is a sudden flash of increased brightness on the Sun, usually observed near its surface. Powerful flares are often accompanied by a coronal mass ejection. Even the most powerful flares are barely detectable in the total solar irradiance. Flares occur when accelerated charged particles, mainly electrons, interact with the plasma medium. They occur above the surface in the corona, and energy deposited at the surface raises a superhot cloud, about 100 million degrees centigrade, which is strong, long-lasting source of X-rays. Flares are brighter than the whole sun in X-rays, and in ultraviolet light. On 17 March 2015, a storm on the sun was so strong that it was strongly felt even on Earth. Solar cycle. The number of sunspots increase and decrease over time in a regular, approximately 11-year cycle, called the solar sunspot cycle. The exact length of the cycle can vary. More sunspots mean increased solar activity flares and CMEs, coronal mass ejection. The sun is in an active phase if it's 11-year solar cycle. South sunspots become north sunspots during the next solar cycle. Impact on Earth. Being the only source of heat and light, sun is critically required to sustain life on Earth. Without it, Earth would just be a lifeless ball of ice coated rock. The sun warms our seas, stirs our atmosphere, generates our weather patterns, and gives energy to the growing green plants that provide the food and oxygen for life on Earth. Since the initial stages of the Earth, the sun has been an epitome of sealessness. The connections and interactions between the sun and the Earth drive the seasons, ocean currents, weather and climate. Dance. Never to view the sun directly without unaided eyes when it's going through the daytime period, because doing so could permanently damage your eyes. Despite being this important to us, sun is not an all-good entity for us. Direct contact of rays emitted by sun could harm your skin brutally. And for that we owe the ozone layer surrounding the Earth. We also need to kneel down before atmosphere for albedo effect, reflecting up to 70% of sunlight back into space, which has kept and been keeping us protected. Fun fact here is, the UV radiation in sunlight has both positive and negative health effects, as it is both the principal source of vitamin D3 and a mutagen. Probable fate of our star. The sun is on the main sequence, the most prolonged and most stable phase of a star's life, marked by the fusion of hydrogen in the stellar core. After main sequence, it will face a long and complicated series of transformations, some of which will probably be catastrophic for the final destiny of the Earth. This main sequence of sun lasts for 10 billion years. And our sun has reached almost halfway its mark. The nuclear fusion that feeds the mechanism produces energy at a rate neither too fast nor too slow, sufficient to balance the centripetal push of gravity, with an equivalent pressure directed outwards. The star thus remains indefinitely in hydrostatic equilibrium. In the battle between gravity pulling inwards and nuclear fusion pushing outwards, there would be the efforts amongst both to dominate. Approximately, after 10 billion years, the fuel present in the sun would be exhausted, and the phase of transformation would begin. Then, the fusion would be carried by transformation of helium into heavier elements. Eventually, the sun will swell to become a red giant. Then, it will shed its outer layers and the remaining core, and will collapse to become a white dwarf. Slowly, this will fade and enter its final phase as a dim, cool object known as a black dwarf. If still, you do have any fragment of doubt about the prominence of our star, let's get this straight. Sun contains 99.86% of our solar system's known mass, and gravitationally dominates it. Our star has always been there for us since dawn and while evolving. Still, shows up in the mornings to make them beautiful and for life to exist, experience, interpret and learn via this beauty. We being busy, making a living, sometimes forget that there's that self-luminous body to which we owe our existence, and we don't even once look at that sky, closing the eyes and just feeling that wholehearted gratitude.